Okay, so I've posted a new package of questions on rate, ratios, and proportions. So I thought I'd create a video working through those questions. Okay, these questions come from what's called the EQAO, and this is just a province-wide test that all grade 9 students in Ontario take at the end of their course. So you will see questions like this when it's your time to do the EQAO. So let's read through these questions and let's make sure we highlight any important information. Question 1 says, on a sunny day, a flagpole that is 5 meters tall casts a shadow that is 2.8 meters tall. So we have a flagpole here, and this is the height of the flagpole, right, from here to here. And it casts a shadow that is 2.4 meters long. So here's the length of the shadow, right, from here to here, okay, as shown below. At the same time, we have a tree that's next to the shadow, a tree that's next to the flagpole, and it casts a shadow that is 3.6 meters long. Okay, so we have a flagpole that's 5 meters tall, and the shadow is 2.4 meters. And we have some tree where we don't know the height, but we do know that it casts a shadow that is 3.6 meters. Okay, so what we do know is that because this is happening at the same time of the day, right, it says at the same time, the sun is going to be in the same angle in the sky. So what that tells us is that we can create a proportion between the height of the object and the length of the shadow of the object. Okay, so again, we don't know the height of the tree. Don't know height of tree. Okay, so which of the following proportions can be used to determine h, the height of the tree? So we'll say that this is h, the height of the tree. Now remember, when we set up a proportion, we have to have the correct number in the correct position. So for example, if I create a proportion, remember a proportion is just setting two ratios or two rates equal to each other. Okay, so if I put the height of the object on the top of a ratio and the length of the shadow on the bottom of the ratio, then I need to do the same thing on the other side. So I need to make sure that the height of the other object, which in this case is a tree, is aligned, right? It's aligned with the height of the other object, which is a flagpole. And then similarly, the length of the shadow would have to be on the bottom. So we have to make sure that they align up and down too. So on one side of the ratio, I'm only talking about the flagpole, right? And on the other side of the ratio, I'm only talking about the tree. Okay, we can't get our numbers mixed up because there's actually 4 places that we can put our numbers. 1, 2, 3, 4. And we have to make sure we put them in the correct position. Okay, so if we look at our first ratio, we have h on the bottom. Okay, so remember, h represents the height of the tree. So if we have the height of the tree on the bottom, then that must be on the other side on the bottom. This must be the height of the flagpole. And we ask ourselves, is that true? And yes, it is, right? 5 meters for the height of the flagpole. And on the top of the ratio, because on the left side we're talking about the flagpole, right? That means that this top position needs to be the length of the shadow of the flagpole. And it is, right? 2.4. So that's good. And on the other side, right? The other side, we're talking about the tree, right? This is all these numbers are related to the tree. So on the top, we should have the height of the shadow of the tree, and we do. So actually, this proportion is correct. So this is the correct way to solve the proportion. So that is, the answer is going to be A. Let's just simply look at why the other ratios are not correct, because that's going to help you guys with your understanding. Okay, so if we look at the proportion B, the second proportion, why is the second proportion not going to help us solve the problem? Well, let's look. If we have H on the top, H represents the height of the tree. So on the other side on the top, we should have the height of the flagpole. But this is not the height of the flagpole. That's the length of the shadow. So again, our numbers are not being lined up correctly. And similarly, on the bottom, we have the height of the pole, the flagpole, but it's across from the height of the length of the shadow of the tree. So again, our numbers are not aligned correctly. Okay. If we look at C, we can see that H is on the bottom, and we can see that, so that's the height of the tree, and we can also see that the height of the length of the shadow is on the top. But then on the other side of the ratio, we have 5/6. And I don't even know where the number 6 comes from, but it's not a number that's located in our problem, right? So that can't be right. Like, where did the 6 come from? And similarly, we have the same thing going on here. We have a 6. Well, the 6 was nowhere in our problem. So that explains why A is the correct one. Now, another correct one, another way we could have done this is we could have done 5/2.4 is equal to H/3.6. So again, in this ratio, we have the height of the objects on the top of each ratio over the length of the shadow of each object. So this this proportion, in addition to this one, would also help you solve for H correctly. Okay, question 2. DJ Cool is a disc jockey who charges the same amount for each hour. For a 4-hour dance, he charges $522. How much does DJ Cool charge for a 7-hour dance? So again, we're going to set up a ratio. And in order to line up our numbers correctly, I'm going to create this kind of help. So I'm going to write price. When I make my ratios, I'm going to put price on the top, and I'm going to put number of hours on the bottom of each ratio, actually each rate. So I know that he charges $522, and that's for 4 hours, okay? Now, what I want to know is I want to know how much he charges for 7 hours. But I don't know, so I put an X to solve. Now, sometimes we can solve proportions using a scale factor, but here we cannot. So what we're going to do is we're going to multiply both sides of our equation by 7 hours. And we do that because then it cancels that term out and it leaves x all alone. And that's how we're going to solve for x, by getting it to be all alone. So then we just have to multiply 7 hours by $522 and divide it by 4 hours. Okay, and that will give us our price, the amount that the DJ charges for a 7-hour dance. So 7 times 522 divided by 4 is $913.50. Remember that 0.5 at the end, money always has 2 decimal places. So you add that 0. So G is the correct answer. Okay, question 3. Study the distance chart below. So here's our distance chart. And basically what a distance chart is showing us is it's showing us the number of kilometers between each town. So for example, the distance between Calgary and the city of Banff is 128 kilometers. The distance between Columbia Icefield and Banff is 188 kilometers. The distance between Columbian Icefield and Calgary is 316 kilometers. The distance between Edmonton and Banff is 423. The distance between Edmonton and Calgary is 295. And the distance between Edmonton and Columbian Icefield is 461 kilometers, and so on, okay? So you get the idea. So the question continues. Tim drives from Edmonton to the Columbia Icefield at an average speed of 60 kilometers per hour. How long does his trip take? So first we need to identify, right, the distance between Edmonton and the Columbia Icefield. So the distance between Edmonton and the Columbia Icefield is 461 kilometers. So I know, right, if we're driving at a rate of 60 kilometers an hour, I know that we travel 60 kilometers in 1 hour, right? That's what 60 kilometers per hour means. It's a unit rate. And I want to know, how long will it take to drive 461 kilometers, right? I want to know how long it will take. So I put X for the time because that's what I'm trying to figure out. Okay? So what I'm going to do now is I have to solve for X. And this is one of those scenarios where X is on the bottom of a ratio. So one method that we can use is we can flip both sides of the ratio. So I could rewrite this as 1 hour over 60 kilometers is equal to X hours over 461 kilometers. And the reason I do it is because it's easier to solve for a variable when the variable is on the top of a ratio or rate. So now our next step is going to be to multiply both sides of our equation by 461 kilometers. And we do that so that it cancels out and we're left with just X all alone. So to solve for X, we do 461 times 1 divided by 60. And that's going to give us, I'm going to round to 1 decimal place. That gives us 7.7. It says 7.68, but I'm going to round 7.7 hours. Okay. Now, 7.7 hours, that is much closer to 8 hours than it is to 7 hours, right? We would round that up to 8 hours. So D is the correct answer. Okay, question 4. Paper is sold in different sized packages. Which package has the lowest cost per sheet? Okay, so here we have to find the unit price. Okay, now remember, money always goes on the top of your ratio. So for A, let's find the unit price for that package. So $1 divided by 150 sheets, the unit price is going to be, well, we do that division, 1 divided by 150, and we're going to get 0.0066 continuing. So when we continue, we can put a little bar because that means the 6 continues forever. Okay, and that is dollars per sheet. The unit is dollars per sheet. Okay, next let's do the second one for B. I'll use a different color here. So now we're going to do $1.20 for 200 sheets. Okay, so let's do that division and let's find the unit price there. So 1.2 divided by 200, that gives us 0.006 dollars per one sheet, per sheet. Okay, next one. $2.50 per 500 sheets. Okay, so we do that division, 2.5 divided by 500, and we get 0.005 dollars per sheet. And I'm keeping all of these decimals because I need to be able to compare the numbers at the end, and they're all pretty small numbers. All right, last one. We have $5.50 for 1,000 sheets. Okay, and again, we can do that division. We're going to get 0.0055 per sheet, per one sheet. Okay. Now, when we're comparing decimals, it's always a good idea to make sure that all of the numbers have the same number of decimal places. So this one has 1, 2, 3, 4. So I'm just going to edit the other ones to make sure it has 4 as well. So I'm going to write this as 0.060 and the next one as 0.050. You don't have to do that. It just helps visualize. So now, to identify the smallest one, you're looking at the last 2 decimal places. Okay, so which one has the smallest price? Well, it's clearly this one, right? That's the smallest one, C. So that package has the lowest cost per sheet. Question 5. Emily burns 2,500 kilojoules per hour when she runs. To regain the energy she spends, Emily eats apples. An apple gives her 420 kilojoules of energy. How many apples must Emily eat to regain all of her energy when she runs for 1 hour? Okay. So based on the unit rate that is given to us, right, that rate tells us that she burns 2,500 kilojoules in 1 hour. That's what the unit rate means. Okay, so if she goes for an hour run, she's going to burn that many calories. And what we want to know is we want to know how many apples she needs to eat in order to replace all of that energy. So we know that one apple gives her 420 kilojoules. Okay? And we want to know how many apples, so X for how many apples will give her 2,500 kilojoules. right? That's what we're trying to figure out. How many apples does she need to eat to regain all 2,500? So again, we're going to solve this the way we always do. We're going to multiply both sides by 2,500 kilojoules. And that cancels that out. That leaves x all alone. And then to solve for x, we do 1 times 2,500 divided by 420. And that's going to give us a decimal. So it's going to give us 5.95 approximately. So that's about 6 apples. About 6 apples. So that is answer A. Okay. Examine the diagram below. So here we have a rectangular prism. Which statement is true? The height is 40% of the width. Okay, so remember 40%, that is 40 over 100. Okay, so we're saying the height is 40% of the width. So the height, which is 40, is 40% of the width. So this is the height over the width, which is 50. Well, there's no way those two are equal, right? Those can't be equal because one has a scale ratio of 1, scale factor of 1, and the other has a scale factor of 2. So that cannot be true. Okay, let's look at the next one. The height is 50% of the length. So remember, 50% is 50 over 100. And we're saying the height, which is 40, is 50% of the length, which is 60. Okay. So are those two proportions equal? Can we simplify them to the same lowest terms? So 50 over 100 can simplify to 1 over 2. 40 over 60 simplifies to 2 over 3. And those are not equal. Okay, so again, this cannot be true. So let's try C. So the height is 80% of the width. Let's try that. So 80% is 80 over 100. And we want to know, is the height, which is 40, 80% of the width, which is 50. Okay, so let's check our scale factors here. So here we have a scale factor of times 2. And here we also have a scale factor of times 2. So that means this is correct. Okay, so C is the correct answer. Now for D, let's just prove that D is not true. So 125%, that's 125 over 100. That's 125%. It's saying the height, which is 40, is equal to 125% of the width, which is 50. Well, that's clearly not true, right? Because here we have a scale factor of times 2, and this is not a scale factor of times 2, right? That's a different scale factor, so this cannot be true. So that kind of shows why C is the only one that is correct. Question 7. In 2003, 50% of the 64 members of an environmental group voted to protest a new development. So 50% of 64 members voted to protest a new development. In 2004, with a membership of 40% voted to protest the same development. Okay. How many more members voted to protest the expressway in 2004 than in 2003? So this is your hint here that it wants to find the difference. Find the difference between the number who voted in 2004 with the number who voted in 2003. So find the difference. And that means you're going to end up doing a subtraction in the end. Okay? So in 2003, let's figure out how many people voted. So again, I'll just write 2003. So 50%. So 50% is 50 over 100. 50% of 64 members. So all we have to do is solve for x, right? We multiply both sides of our equation by 64, and we cancel that out, and that just leaves us with x is equal to 64 times 50 divided by 100. That's going to give us 32. 32. So in 2003, 32 members voted. Let's do the same thing, but for 2004. So in 2004, just go over here, only 40% of members voted. But there was 85 members. So what's 40% of 85? So again, we solve by multiplying both sides of our equation by 85 to cancel that out. And that is going to leave us with 34. So in 2004, 34 members voted. So the question is, how many more members voted in 2004 than in 2003? So if we look at these two numbers, right, 34 minus 32 is equal to 2. So in 2004, 2 more members voted than in 2003. Okay. The ratio of boys to girls in Mr. Dilworth's music class is 18 to 12. What percentage of the students are boys? Okay. So we have to follow the order of the word. Girls to boys. Okay. And it says we have a ratio of 18 to 12. Well, in order to find the percent of the students that are boys, we need to know how many students in total there are. So total students, what we have to do is we have to add up the boys and girls. So it's 18 plus 12, right? And that gives us total students of 30. There's 30 students in Mr. Dilworth's class. So to find the percent that are boys, and remembering that 12 is the number that goes with boys, to find the percent boys, what we have to do is we have to say, okay, 12 over 30, and because it wants a percent, we want to find x over 100. Remember, percent is over 100. So again, all we have to do is solve for x. So multiply both sides of the equation by 100, and you are going to get an answer of 40%. 40%. So 40% of the students in Mr. Dilworth's class, music class, are boys. Okay, I'm going to pause here, and I'm going to create a second video that will go over some of the other questions. But I think this should be good to get you guys started and kind of build your confidence with these questions.